All right, we're going to continue with 4.4. We started this on Friday, but we only stuck to our angles on the unit circle. Now we're going to talk about, okay, what if we don't have special angles? What's our strategy? So the first thing we need to talk about is reference angles. And you've kind of been using reference angles without me actually calling them reference angles. Okay? But if an angle is in standard position, then the reference angle, we call it theta with a prime on it, is formed by the terminal side and the horizontal axis. I'll let you write down the definition, and then we'll draw some pictures and talk about what they look like and why they're helpful. Okay, so I'm going to direct your attention to these over here. I want to talk about how you've been using reference angles. You know that's what they were. Okay, all of these pink triangles that we made for our unit circle, they all have a reference angle of 30 degrees. They are all 30 degrees away from the x-axis, and that's why their trigonometric values are similar. They just differ by a positive or negative. Same thing with the blue. The blues all have a reference angle of 45 degrees. The greens all have a reference angle of 60 degrees. They're all 60 degrees from that horizontal axis, okay? So you've been working with them, and you worked with them last year, but let's just get some pictures to kind of remember what the strategy was to find them when they're in the different quadrants, okay? So the first quadrant is easy. If you have an angle, if you have an angle in the first quadrant, then that is your reference angle. If it's acute, that's the reference angle, okay? So a reference angle really isn't a big deal when we're in the first quadrant, okay? But we're going to use the knowledge of that triangle to help us when we have reference angles in the second, third, or fourth quadrant. All right. So let's talk about if we had a second quadrant angle. Okay. So here's an angle in the second quadrant. Okay. If we want the acute angle between the terminal side and the horizontal axis, we're talking about this guy right here. Okay. How much more do I need to rotate to get to that horizontal axis? Okay. Now, if we were to calculate this, like we knew the measure of this red angle, how would we determine what that reference angle was? Okay, whatever theta is, we can take 180 degrees and subtract that out. If we're talking about radians, we would say pi minus whatever that angle was. Radians, I feel, is what we're going to be probably the most uncomfortable with, if at all. But I'm going to put them up there in radians since we seem to be a little bit more solid with our degree measurements. All right, let's look at a third quadrant angle. Okay. And here's where we need to be careful. We always want to go back to the horizontal axis. That's how we get our right triangles drawn. Okay, so that the opposite and adjacent sides are where they need to be for our trig ratios. So if we were to go back to the horizontal axis, we're talking about this acute angle right here. What did we rotate past pi or 180 degrees to get to that terminal side? If I wanted to calculate the measurement, what would we do with that red angle? Well, since we're going back to the x-axis, I think we should stay away from 270. I would focus on either 180 or 360 since everything is in relation to the x-axis. So,
could we add one?
Well, I like what you're thinking. Okay, we basically want to know how much we add after 180. But if we know the red measurement, how do we get that blue?
Oh, we should take the red measurement by
Okay, so we're taking our angle bigger than 180 degrees and subtracting out, I'm going to call it pi in radians, okay? So we can see what's left to rotate after we get to pi. And then if we have a fourth quadrant angle, our Pac-Man here. Right, don't you think it looks like a Pac-Man? Do you know what Pac-Man is? At least some of us do. All right, so the acute angle to the horizontal axis would be this guy right here. So if we wanted to calculate this reference angle, yes, we would do 360 or 2 pi radians and then subtract out whatever your fourth quadrant angle is. Okay. Now, if we have angles that are either negative or go past one rotation, then we may need to think about the coterminal angles in terms of how to get the reference angles, but you've been working with coterminal angles for a few days now, so that should be okay, right? So we're going to do 3 examples of reference angles and then get into actually finding some trig ratios, all right? So we will start off with an easy one. It's in degrees, okay? Go ahead, write down 325 degrees, and then I would like you to sketch this angle. Sketch the angle of 325 degrees. And since you've had some work with the unit circle, you can kind of guesstimate where this is going to fall in that specific quadrant. Madeline, which quadrant are we talking about here? The fourth quadrant. Okay. There is 325 degrees, so we need to find this reference angle right here. Okay. Reckon, how are we going to get that measurement?
360 minus 325.
So we have a reference angle of 35 degrees. Okay. I know that you can do that in your head, probably, or in your calculator. But I would suggest when you're doing your homework tonight, actually write that you took 360 minus 325 in case you come back to this homework assignment to study. Sometimes it helps to know where the heck you got a number from. Okay. All right. Next, please plot 7 pi over 5 on your coordinate plane. As you're thinking about where this should go, it's okay to think about the fractions without pi. You know that this is 1 pi. You know this is 3 halves pi. And you know that this is 2 pi. So where does 7/5 pi fall in terms of those 3 values right there? Okay. Is 7/5 more than 1? Is 7/5 less than 2? Okay, so now we need to decide if it's smaller or bigger than 3 halves. So is 7/5 smaller than 3 halves? Okay, not by much, right? But it's smaller. So this angle would need to fall in the third quadrant, but closer to 3 halves pi than 1 pi. So here's our reference angle right here. Ryan, how are we going to figure out the measurement of that angle? Okay, since it's past pi, we're going to have to take the angle and then subtract pi. Very good. Okay, so I want you to think about common denominators. 1 pi is the same thing as 5/5 pi. So our reference angle is going to be 2 pi over 5. All right, do not let this one throw you for a loop. 2.3. Okay, so first of all, is this degrees or radians? Radians, because there's no degree symbol. Okay, now, do you see a pi? No, don't put one on there. There's not one there. Pi is already multiplied in. Okay, so what we need to think about, okay, this is pi, but in decimal form, it's 3.14, blah, 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 right? This is pi over 2, which is 1.57, blah, 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 right? So 2.3 is going to fall, maybe not exactly there, but somewhere in that second quadrant. So to get that reference angle, we're going to have to take pi minus 2.3. Help me out. What is 3.14 minus 2.3? Devin, did you put that in your calculator? What is it?
0.8415.
Okay, what is it? 2 decimal places? So very careful. Is there a degree symbol or not? All right. We get so used to seeing those radian measurements with a pi attached to it, especially since we've been working with the unit circle for an entire week. All right. But if there's no degree symbol, radians, even though there's not a pi attached to it, it's just multiplied. Okay. All right. So just as a reminder, because now we're going to get into some trig functions. Okay. Just as a reminder that everything is positive in the first quadrant. Of the three major trig functions, only sine in the second, only tangent in the third, and only cosine in the fourth. All students take calculus. Okay? Next week we're actually going to start signing up for classes. So juniors and sophomores, I'm going to start talking to you about what you should take next year. Anyway, we're going to do three different types of problems. Okay, here's the first one. Here I have an angle theta, and it looks like the coordinate -3, -2 is on the terminal side of the angle. How about you go ahead and like at least somewhat draw the picture? Okay. You at least need this angle right here with -3, -2. Now, when we were on the unit circle, we could say that the x value was the cosine and the y value was the sine. If our radius is not 1, it does not work. Okay? So this looks pretty nice because it's on a circle, but that radius is not 1. And so -3 is not our cosine, and -2 is not our sine value. Okay, but what we can do, okay, yes, we're not on the unit circle. However, we have this knowledge of reference angles. And a reference angle is acute. And with an acute angle, we can draw a right triangle. If we have a right triangle, we can pick out sine, cosine, and tangent ratios. All right? So what our job is going to be here is to draw a reference triangle. And in our reference triangle, we have a side right here that is 3 because the x-coordinate is 3. And the y-coordinate is -2, so we know this has length 2. And to find the hypotenuse, what are we going to use? The Pythagorean theorem, which would give us radical 13. Okay, now I'm going to give you a couple different ways to think about this. Okay, here I have a triangle drawn where I have positive lengths for our sides because that's how a triangle works, right? We have positive lengths. Okay, and in our reference triangle, it's going to have the same trig ratios as theta, but it's in the third quadrant, so we're just going to have to be careful with our positives and negatives. We know that in the third quadrant, sine and cosine are negative while the tangent is positive. Okay? And now we can just use our reference triangle to get our values. So sine, opposite over hypotenuse. And then we would rationalize. Cosine, negative because we're in the third quadrant. We're going to use our reference triangle for adjacent over hypotenuse. And then we would rationalize. And then for tangent, opposite over adjacent. Okay. Now, for your reciprocal functions, please be smart about what you're taking the reciprocal of. For example, if I'm going to do our cosecant ratio, I know that the cosecant is the reciprocal of sine. Ladies and gentlemen, if I take this right here and make it a reciprocal, I'm going to have to rationalize the denominator again. But I know that this is equivalent to this non-rationalized fraction right here. If I flip the non-rationalized fraction, I don't have to do any extra work. Okay? You're going to get to the same place, but with less work. And I think you all would appreciate it. Okay? For our secant ratio, same thing. Let's flip this one. Negative radical 13 over 3. And then our cotangent ratio is going to be a positive 3/2. Now, the way that we just did this problem, we labeled our triangle with positive lengths. I thought about where the reference triangle was, and I made my positives and negative signs accordingly. If you're worried about forgetting that, and you want to label this as a -3 and a -2, I really have no problem with that. I know that those lengths aren't negative, but if it helps you get the appropriate ratios for your positive and negative values, that is fine. Okay? I think we all understand at this point in our math career that a triangle can't have negative lengths. But if you label them that way just to get your ratios, we'll all be okay. All right, 2 more problems. Here's one very similar to what we just did, except there's no picture. All right, so go ahead and write down that -3/4 is a point on the terminal side of theta. Okay, when we are doing anything with right triangle trig that does not involve one of our special unit circle angles, there should be a triangle. Okay, if it's 30 degrees, 60 degrees, 210 degrees, we're just going to remember those. But anything else that's not a special angle, there needs to be a picture. So in my coordinate plane, we need to plot the point -3/4. Okay, so technically, this is our angle theta. Okay, but what we're going to do is we're going to use a reference triangle to get the sine and cosine and tangent ratios in the second quadrant. So once again, we don't have a radius of 1. So we can't use like x is cosine, y is sine. That only works on our unit circle. So what we can do is we know that this is the reference angle right here. And we can draw a right triangle in the second quadrant to get our ratios. Okay. We know we went over 3 and up 4. Now, how many of you like the idea of labeling that as a -3 on the triangle? No, not really? Like you're fine just leaving it as a normal 3? Okay. But we're in the second quadrant. So when I write sine, cosine, and tangent, you are going to have to remember that the cosine and tangent are negative and the sine is positive. You're not going to label it as a -3, you're going to have to remember that. Okay. Now this is nice. What's our hypotenuse? 5. So our sine ratio is a positive 4/5. Our cosine ratio is a negative 3/5. And our tangent ratio is a negative 4/3. So we either put the plus or minus signs here, or we label that as a -3 and they work out in the ratios the way that they need to be. All right, one last type of question, and this is a pretty popular question. I can guarantee you'll see these pop up so not only will these types of problems pop up on quizzes and tests, but these also, where I'm going to give you a trig function ratio, and you need to find me a different trig function ratio. So go ahead and write down this information first, so that when you look back in your notes, you know what's going on. Okay, so if the tangent of theta equals -5/4, where is the tangent negative? The second, second, and the fourth. So if the tangent ratio is a -5/4, how do I know where to draw my triangle? Should I just draw a random floating triangle? No.
It tells us that it goes over 5 and up 4.
Okay. We know that this is y over x, so we know. But is it -5/4 or is it 5 over -4? How do we know? Yeah. Okay, we know that the cosine is greater than 0. So if the tangent is negative in the second and fourth quadrants, which one will win? The fourth quadrant's going to win because that, of the two, is where cosine is positive. Cosine's negative in the second quadrant, so we don't care about that. So when we go to draw our reference triangle, yes, it has a tangent ratio of 5/4, but in this case, it's the 5 that's negative because we're in the fourth quadrant. What would our hypotenuse be? Not quite. It's a little bit under 7. Radical 41. Now, where I find people getting into trouble in this type of problem is they just draw a floating triangle. And they figure out what the hypotenuse is, and then they label all of their ratios, but they're all positive. They didn't even think about what quadrant it was in. So please make sure you draw a reference triangle in the specific quadrant. Okay? And since we're in the fourth quadrant, the cosine / secant ratios are positive. The rest are negative. If it helps for you to label that 5 as negative to get your ratios, you can do that also. All right, so our sine ratio is -5 over radical 41, which we would rationalize. And then we would take the reciprocal for the cosecant. Our cosine is adjacent over hypotenuse, which we will have to rationalize. And then take the reciprocal for the secant. And then the cotangent is just the reciprocal. And that one you can get without drawing a triangle.